All right, so Mr. P helps with Algebra 2, Unit 2, Topic 2, SLT number 12. And we're going to be talking about polynomials and even and odd degree functions. We're talking about key features of polynomial functions and specifically talking about how even and odd functions are different. When you have an even and odd function, this one kind of goes with what we're doing in this lesson. As a matter of fact, it's kind of a review lesson of the last, if you watched the last video. If it's an odd degree, meaning that the largest exponent is an odd number, then you know the function is going to have two ends where one's going up and one's going down. Now, it might be the opposite. It might be going like this, where the left side's going up and the right side's going down. And if you have a even degree, meaning that the highest degree is an even number, then you're either going to have both arrows pointing up or both arrows pointing down. Now, the bigger the number, it's always going to look the same. So x squared, x to the 4th, x to the 6th, x to the 8th. You're going to have a longer stay in the middle by the bigger exponent, but for the most part, it's going to have the same general shape to it. It's still going to be a parabola type shape. Describe the end behavior of this function. So this is an odd degree. Now, the other thing I didn't talk about is the leading coefficient, meaning whether or not the largest degree is either positive or negative will determine which one it is. If it's positive, it's going to be going up from left to right, and if it's negative, it's going to be going down from left to right. So now this is a positive degree. It's also odd, so therefore it's going to look like this one, which means as x gets further to the left, the height of the function is going to be going down further. So the further I go to the left, and it's going to go infinitely to the left, it's going to go infinitely down. And as the further I go to the right on this function, the further it's going to go up towards positive infinity. Pen. Thank you, Pen. All right, so question number 2. Now it's just a matter of understanding, well, that's pretty much the exact same question because it's a degree of 3 again, and it's positive, and the only difference is this plus 4 out here, which just means that it's going to have a higher y-intercept, which doesn't really matter in this case. It's going to have the exact same end behaviors. It's going to be going down when it goes to the left, and it's going to be going up when it's going right, positive infinity. End behavior in this question, once again, it's still an odd degree, and it's still a positive coefficient, so therefore it's going to be the exact same answers again. This one is an even degree, so we know it's going to look like one of these two, and it's a positive in front because there's no symbol. No symbol means it's positive, so it's going to look like this one. It's going to be going up and to the right, and if it's, okay, this is actually going to the left, and as you can see, my pen is malfunctioning. So if you go to the left, it's going up, and if you go to the right, it's also going up. And I'm going to reset this board here in a second. All right, so here's your homework check. It's basically just determining what type of function it is. It's linear if it's a degree of 1, it's quadratic if it has a degree of 2, it's cubic if it has a degree of 3, quartic if it has a degree of 4, and anything above that would just be a polynomial function. Just means many. Our second homework check is very much what we were just doing a second ago for the warm-up. All right, so end behavior. So kind of just going over what I just talked about for key features again. There's a few more key features here other than just end behavior. So as x is going further to the left, so the further I make the x to the left, the further it goes down. And the further I go towards positive infinity on the x, because this is the x, the further I go to the right, the further the function goes up. Because as I go to the right, this function is going up infinitely. Now, I'm not saying going to the right is always going up, because from here to here, when you're going to the right, you're actually going down. But as you go towards infinity, and that's what it says right here, then the further you're going to go up. So you're only going down for this short amount of time from 0 to 4, but then from 4 to infinity, it's going up. This is going to be an odd degree because, as mentioned before, one side's going up, one side's going down. X-intercepts. The x-intercept is at 0. That's the only, I'm sorry, 0 and 6. It hits the x-axis twice right here and here, and it only hits the y-axis once at 0. Because if it hit the y-axis twice, it wouldn't be a function anymore because it wouldn't pass the vertical line test. This is increasing and decreasing. The interval is The interval on which f is decreasing, as I had mentioned before a second ago, that's only when x is between 0 and 4. And anytime x is less than 0, it's going down. Wait. Do I have that backwards? I'm sorry, it's going up. It's going up anytime x is less than 0 and when x is greater than 4. The minimum occurs in this case. So maximum, minimum, there is no minimum and there is no maximum because it's going to go. So if we were talking relative minimum and relative maximum, then those would be these 2 points. I'm actually not sure which one this is. So there is no minimum. It's going down towards negative infinity and it's going up towards positive infinity for maximum in this case. End behavior. All right, so remember, this is going up and this is going down infinitely. So the further I go to the left, the further it's going up. The further I go to the right, the further it's going down, which makes it an odd degree because these two are different because it's one's going up, one's going down. They're not both going the same direction. The x-intercepts are at negative 2.64, 1, and 2.52. So there can be several x-intercepts. The y-intercepts, remember, there can only be one if it's still a function. That's negative 4. It's increasing, decreasing first. Okay, so it's decreasing when x is less than negative 2, and it's also decreasing when x is greater than positive 2. So it's decreasing here and here, and everything in between is going up. So between negative 2 and positive 2, it's going up. So anytime x is between these two. All right, the relative minimum is right here at negative 20. So that's the lowest point. We're not going towards infinity in this case, just the in-between, and the relative maximum, which is right here at 12. And I think I'm going to stop right there. So we're talking about key features. Thanks again for watching, and have a great day.